always a good thing. And first up, well, the rules of lightning talks is that they are constrained to 10 minutes, so I'm going to have the clock on and give people a bit of a warning, and then when 10 minutes comes, I'm just going to give them a kick and they fall down here. So first up, Pete Losher, a decade of F-root servers in the APNIC region.
Thank you, Dean. My name is Peter Losher. I know many of you have met me before, either doing F-root installs throughout the region or at these conferences. It's good to be back. I've been away the last couple of years. So what I'm here to talk about is a decade of F-root in the APNIC region. Let's skip that. So first off, I can only speak for F-root, obviously. I can't speak for any of the other root server operators, but if you do have questions about their deployments in the APNIC region, feel free to contact them directly. So how did F-root start? We started in the we as an ISC started operating F-root in the mid-1990s as ns.isc.org. It was all in the Bay Area. It was a little i3-86 server. I'm sure the Raspberry Pis of the world now are about 20 times as powerful. Then we migrated onto a pair of DEC Alpha servers that took half a cabinet and were great space heaters. They originally served the ComNet, Org, Edu, and ARPA zones, but that soon drained over time, over the preceding decade, where the GTLDs moved to their own delegated servers. The VeriSign-operated GTLD servers, affiliates with .org, etc. And after that, the ARPA zones have also migrated to DNS servers operated by the RIRs. So why was Anycast needed? Well, we needed to do that to expand the root server footprint geographically. Now, I should mention here that mroot, which is operated by Wide, is in JPRS now, was already in the region, but they were basically only in Tokyo, and I think they might have expanded to Seoul by then. No, I think they were still in Tokyo, but they were in region. So we wanted to expand the footprint of the root servers, whether it was F or someone else. We didn't necessarily care at the time. We just needed to do it now. So we did it for that. We did it for performance, because back when we started, most of the root server traffic was going to the US, unless you were going to mroot or you were going to kroot and iroot in Europe. So if you were in, say, Australia, you were sending all your traffic back to, if you were lucky, either mroot or you were sticking it with those of us who had root server instances on the west coast of the US. We also did this to help distribute coverage to diffuse future DDoSes. That way, when someone tries to DDoS, they're not trying to hit one point, they're trying to hit multiple points. Or if they hit one point, the rest of the infrastructure isn't affected. And also, and slightly more importantly, with the root servers no longer serving the GTLD zones at the time, the hardware requirements went way down. When we started, or when we had those DEC Alpha servers, the reason we had them was because they were the only ones that could take 8 gigs of RAM and did 64-bit. Obviously, when we stopped serving ComNet org, the requirements went way down. We could just stick it on normal PC hardware, and that was easier to buy. So the cost, instead of paying several tens of thousands of dollars, went down dramatically. So we started our first global Anycast node in Madrid in 2002. I remember Paul sending an email going, "We're live," and I went, "Oh, I didn't know you were in Madrid." Soon after that, we started talking to APNIC to sponsor nodes across the region. It's non-exclusive. They obviously deal with other root server operators in the region. We also deal with other organizations in the Asia-Pacific region to sponsor nodes. The first APNIC sponsored node was in Hong Kong in January 2003, and we've quickly expanded over the next decade. And the agreement that we've had with APNIC has been the basis of future agreements that we did with other RIRs, including LACNIC and APNIC. So we now have global nodes in the US, basically in the San Francisco Bay Area, Chicago, New York City, and Atlanta. There we advertise a covering /23 and a /47, 23 in v4 space and 47 in IPv6 space. That way, if you can't reach one of our local nodes, which I'm about to talk about, you'll always get a FROOT. And those nodes are actually designed to handle all the traffic if for some reason all the local nodes collapse. They also have much more robust transit, like 10 gig and so forth. Let's see. We have 55 plus local nodes worldwide, including 18 in the APNIC region. They're located at local or regional IXPs or NAPs. We advertise specific IPv4/24 and IPv6/48 to the peering fabric. We use the BGP community string no export to limit exposure because we don't want a node in India to leak IPv4 or leak FROOT's address space to the whole world and have all the traffic go to Chennai because that wouldn't be efficient. And it would probably be hard on the local node itself. We partner with local sponsors to cover the cost of the hardware, as well as an annual sponsorship fee to cover our operational costs. ISC is a nonprofit. Unlike some of the other root server operators, we don't have a dedicated revenue stream, so FROOT basically has to pay for itself. What do we do to give back? We participate, and we've always participated in DNS OARC's Day in the Life, where we take 24 hours of root server data and contribute it to OARC for research purposes. We do on-site workshops when doing installs. So many of you, if you've seen us do an install, we usually do a presentation to the local ISP community or do training to try to show them how to use their local node. We emphasize locating at IXPs and NAPs versus doing embedded nodes. We'll do embedded nodes, but we prefer to be at IXs because we believe in the open internet and that peering should be preferred wherever possible. Things we have learned. Shipping gear worldwide is hard. In the early days, APNIC was shipping out the equipment from here in Australia out to all the various nodes, and we were shipping gear from California. Customs is a pain in the butt. And what we've since done is we now source all of the equipment locally wherever possible. Don't skimp on the bandwidth, really. People think that we can just run these things off of a 1 meg DSL line. When you're trying to push through a DDoS attack and you're trying to get packet captures and sending them back for analysis, even if the link is minimal, or the traffic being used is minimal, you still need 5-10 megabits or even more, and that has been an issue for some of our nodes. The less moving parts, the better, and there is such a thing as too much redundancy. What I mean by that is that our nodes right now are 3 servers, and 2 of them are DNS servers and 1's a back-end machine. And when you have one server go down, even if you ask them nicely, a lot of our sponsors say, oh yeah, we'll take care of it, next budget cycle, so forth and so on. When both machines go down, then you get an immediate response and they'll have something the next day. So sometimes it's easier to have something fall fast and fall quickly rather than just try to keep it up out of sheer will and wait and sort of limp along. And also we sort of benefit from the fact that nowadays we have, with the 55 sites, we now have super regionals, or what we call super regional nodes. So if a node in Dhaka goes down, then the traffic goes back to Hong Kong. It doesn't go all the way back to the US anymore. And that's just an account of our aggressive peering policy. Going forward, we're shrinking the hardware requirements wherever possible. We have since gone for some of our smaller nodes to sort of a single router, single server model. But what we're working on right now is what we call F-singles. It's under active development. I've actually got a prototype server sitting in my office right now. What we're trying to do is shrink it all into one box. And we're also hoping to combine that with some of ISC's secondary DNS hosting. We host many Asia-Pacific CCTLDs like Thailand and Nepal, and we'd like to combo that into a single box so you get both the root server and some regional CCTLD coverage. And we're also expanding the location of global nodes outside North America. We'll probably do first Amsterdam, and then we're currently looking for a location in Asia. Part of that is just we need to get enough management transit to support it. Yep. And we're continuing to expand in underserved markets. We're focusing on the Asia-Pacific region, Africa, and Latin South America, and also making more of our stats public. We're doing that in concert with a current proposal in front of our RSAC as part of the ICANN process. And hopefully over the next year, you'll probably see more public stats coming out of F. If you're interested, if you're in a country that doesn't currently have a root server instance, please talk to APNIC, and they'll contact us. I believe APNIC's policy is that they'll sponsor one root server instance per country. If your country wants another instance, you can talk to us or one of the other RSOs that widely anycast globally, including ICANN, VeriSign, NetNod, among others. So that's it. Boy, I timed that perfectly.
Well done, bang on time. Questions?
Not so much a question as a correction. We negotiated the MOU text with Paul Wilson. Then while we were waiting for Paul Wilson to get it approved, Madrid signed it. That's why Madrid was first, but it was Paul's text.
Awesome. So next up, we have Alistair Chapman. Here we go. You're up.
Good. Right, hello everyone. As mentioned, my name is Alistair Chapman. I'm here to deliver a design pattern that I cooked up a little while ago. Now, to get some things out of the way, time is very short. There's a pared down version. It's going to seem a bit odd. But if you've got any questions, I'll be around afterwards and that sort of thing. Now, obviously, everyone's wanting to have a very resilient, very reliable production, high availability environment for critical services these days. As we move towards cloud environments, that becomes a lot easier to spin up a whole series of instances, but they're still not necessarily as reliable as we'd like. So what we're really looking for is something that's going to lead to almost no downtime, is very easy to manage, and is secured against the next generation of threats. Now, this is where it's going to get a bit weird, is that these are the four main principles of my particular design pattern. So the first one is the obvious one of we don't want any downtime in an environment like this. Secondly, we have the concept that hosts have no value in and of themselves. Next, that applications are the main commodity in this environment, and that configuration really needs to be centralized as much as possible. So on to the first one, you guys all understand that downtime is still the enemy. It can be caused by anything, and there's no easy way to protect against every possible instance. It can be caused by someone's server literally exploding, acts of God such as floods going through the building, or your administrator accidentally deleting /bin. Equally, the next principle is the idea that hosts aren't actually, they don't have value in and of themselves. Your customers don't care about your routers, your database servers, how you do your request controlling, or what sort of host backend you're really running. As you try and customize these, they become an administration nightmare later on. So moving to the next principle, which is that applications are king. Your applications are what you're really dealing with and what your customers are facing. They are the thing that must be available at all times. I mean, code that we can run anywhere is a lofty goal, but a very good one nonetheless, because it does mean your applications are portable, they're platform agnostic, and there's a lot of technologies these days that enable that sort of change. And the last one is the concept of data centralization. So if your data is not in source control already, it better not be critical data because you're wasting your time. If you're able to sort of control it all in one area and simply push the data out from that one location, or have all your agents pull it, that's automatically a better layout. Obviously, that also means you should be keeping all of your baseline configuration and data in source control, whether that be the actual application data and configuration, or simple things like your users' dot files, or how you configure your Apache load balancers, should all be equally well protected in source control. Now, for a bit of discussion on how it all actually fits together. That was a lot of information very quickly. It was going to make a bit more sense. So if you're deploying, let's say, this obviously only works for Linux hosts in virtualized environments. If you're deploying a whole series of web servers running an e-commerce application as your example, and one of your back-end servers has its response time suddenly spiraling into the actual seconds. That's going to manifest as a really obvious user experience problem with your users. You're going to go and try and buy something from your site, and it's going to be a slow, painful process with all sorts of browser errors. Now, the usual scenario at this point is that you'd send one of your developers out to have a look at that server and work out why the hell it's taking so damn long to respond. Under this idea, screw that. Don't need to do any error analysis. Simply drop the host, rebuild from your most recent snapshot, redeploy your application, and drop it back into production. If it's a problem that you've seen before, demote that particular host, the problematic one, back into your testing environment, into a quality assurance environment, and have a developer look at it out of band. That way you're not leaving the bad service up for customers to interact with, but you're still able to find the root cause. Now, technology these days has gotten to a stage where that's not actually as impractical as it seems. So an easy implementation is something like Canonical's Metal as a Service function, which builds Ubuntu images on demand, whether they be on bare metal or on OpenStack or any cloud services. Combine that with something like Cobbler to do the bootstrapping, systems like Puppet, Chef, Ansible, Salt, all of those are master server provisioning environments. And in the Windows world, to an extent, you've got the similar sort of capability with DISM, SCCM, and Windows imaging. Now, relying on automation and monitoring is something that's been massively peaking up. That if you're able to monitor your environment at a very granular level with Nagios and Zabbix, and intrusion detection systems are able to develop a very granular view, particularly something like the Bro, and you can have IPS systems and your SolarWinds to manage applications specifically. These is giving you an absolute wealth of data that's not necessarily being used to its fullest extent. Equally, a lot of the systems that you're running on can be automated very easily. Something like vSphere has an immensely powerful API behind it. It's just that most administrators don't tend to use it much. Equally, things like Canonical's Mass I mentioned before and Puppet are very easy to script and automate and deploy on a very large scale, and it's not actually as big a learning curve as many administrators seem to think it would be. So the technologies that really enable this is something like Docker application virtualization. If you take your e-commerce site that runs on an Nginx server and build the whole thing into a Docker container, that can run on any Linux host from the last couple of years. Something like libcontainer or LXC work as viable backends for any Docker containers, and that means you can also easily move it and migrate from one host to as many hosts as you need, and push things like load balancers in front of them to make it appear as a single state. That equally is something that most providers are already trying to avoid single points of failure. So if you're running multiple applications already, it's a lot easier to run multiple instances of the same application than reconfigure over and over again. Equally, technologies like vMotion for the vSphere guys, live migration in Hyper-V world, and Nova migration for the OpenStack guys lets you move your instances of applications, of servers, and of your infrastructure easily around your environment. And one thing I haven't got up there, which is probably useful to mention, is software-defined networking. So as someone pointed out earlier in the conference, SDN is a terrible name for it, but it allows you to abstract that networking technology away from your hardware. You can decouple that even more, which means that you can move your networking configurations around your environment with your applications. Puppet, Ansible, and all your other provisioning techniques are vastly more powerful now than they were even a few years ago. The providers are growing on a daily basis and their compatibility is improving all the time. There's a lot of improvement in monitoring automation now. This one we can thank the DevOps guys. I think they're crazy for doing it, but they are pushing a lot of technology improvements in automation and monitoring because that's their business model effectively. They're trying to move towards having 100% automation wherever it's possible and having a very granular and transparent view of the environment at all times. Combine that with some of the more reliable and easy to implement intrusion detection solutions available these days, whether you go with a vendor solution and combine something like FireMon with Palo Alto machines, or go for a dedicated solution like the open source Security Onion solutions, things like that. That gives you a very good view of the security of your network without having to necessarily perimeterize all your security. Now, how that all fits together is you're able to deploy something like host-based firewalls on every host, deploy your Security Onion monitoring solution for security events, and deploy your Nagios and Zabbix agents in your templates. Now you can build any number of machines off your VMware templates or Hyper-V or any of the equivalents quickly and easily, and just build them out into your environment, as many as you need, and realistically with cloud services the way they are, as many as you can afford. Put load balancing and software-defined networking in front of them to ensure that you have access at all times. And that way that when you then have the inevitable problems, you have someone made a mistake while they were developing some new code and deleted half the website, or whether it be that your application slows down to just an unusable state, You can simply drop the machine, wipe the disk, rebuild from a recent snapshot, and use something like Puppet or Ansible to redeploy your application code directly onto the machine. That's a lot easier with source control code because you can simply push into a production environment, push that out with Puppet, and you have the new version running across your whole environment. We're running a little tight on time, so to sort of summarize what we've got there, those are those principles I brought up earlier, which hopefully make a little more sense now. The hosts and the servers and the instances that you're running in your virtualized environment don't have any value in and of themselves. Their real value is their ability to host your applications. So if your applications are portable services that can be moved from between containers and platforms, you've automatically gained a lot of agility and flexibility in how you deploy that application to a production environment. This enhances vastly better security monitoring. That's something I can't really get into in this time, but allows IDS solutions and host-based firewalls to be vastly more effective because they're deployed consistently across your entire environment without having administrators manually tweaking it all the time. Combine that with automated provisioning to push out your application code and effective configuration management to make sure that you always have a baseline state. And you also have something that's a dream to administer compared to what a lot of people are running today. All the hosts in your environment in this sort of design will be in the exact same configuration, running the exact same version of code, and with advent of things like SDN, even the exact same appearance to the outside. Tools like Ubuntu's Juju and things like that that run as containers that you connect and expose at will is something that that's sort of trying to take, this pattern is trying to take advantage of that capability, that you're able to deploy and expose services no matter what they are very easily and no matter what the backing environment is. Thank you.
Awesome. Thank you very much. Does anyone have any questions? No? Awesome, outstanding. Next up, Skeeve. What I will do, though, is up after Skeeve. Yeah, I know. I'm like that. We have TV white spaces from Sarah Iskandar-Thomas. If you're in the room, Sarah, can you see me? Because we need a PDF of your presentation, and I can sort out how we do that. So, Skeeve, you're up.
Do I click on something?
You haven't got the... You haven't got it? Isolated it. No? Sarah. Yeah, there we go. See? There we go. It's coming. We can see it making its way through. There we go. It'll come up on there as well.
Excellent. Okay. This is essentially, it's sort of a conceptual briefing of something that's actually running in Australia at the moment and starting to head into Asia. It's called Virtual Cross-Connect Fabrics. Now, for many years, keyboard. Okay, so for many years, most ISPs will know about IXs and internet exchanges and multilateral and bilateral peering. So this is kind of a new thing, but not. So it's using basically VLANs. So think of as VLAN peerings, where the reason we call them virtual cross-connect fabrics is that think of a whole bunch of customers just getting to a switch, and rather than doing layer 3, they're doing layer 2 cross-connects to each other. So ISPs have been doing this kind of thing for a long time, but in Australia it's now starting to happen with enterprises. So the trend in the world at the moment is to consume things on demand with no contracts and very quickly. So, and with scalable infrastructure, buy as you go, like Amazon, where you spin up servers and spin them down when you need them. So this is really nothing revolutionary in network infrastructure. It's quite revolutionary in productization. So I'm just giving you a bit of a briefing, as in I haven't heard of it too much, and it's outside the Australia, and it's about to launch in Singapore and then Hong Kong in the next few months, with a couple of providers, and with one provider that I'll go into in a second is already in multiple countries in Asia. So what is a VSE fabric? It's basically a layer 2 brokering system using VLANs, extreme high speeds, so most buy-ins are at around the 10 gig range. On-demand provisioning, so with web portals, 60 seconds, and you've got 10 gig cross connects and things like that, and it's very, very easy to use. So this is kind of what it looks like. So think of a layer 2 fabric like just a large big switch, but normally a switch is inside an organisation. Imagine a switch that many organisations shared and could create VLANs to each other on demand. So you've got examples here of compute storage. So in Australia, people like AWS are already online. Azure is just coming online, and you can actually do a cross connect from your own network over the fabrics and straight into Amazon and then to their compute space. So you're not using their internet, you don't have to use their internet, and you can use it as your capacity. So the current fabric providers in Australia are Megaport, IX Australia, and PACnet, and I believe NextGen's coming soon. They've sort of announced that it's coming, but haven't given us details of when it's arrived. Now, Megaport is in most of the east coast of Australia, and I think they're going west coast soon. Generally, the way it works with Megaport is that across all the data centers, so Global Switch, Equinix, there is a fabric that if you are on this fabric, you can create a VLAN to each other for a single small price on a per day basis. So like $20 per day will buy you up to a 10 gig cross connect. So this is basically on demand. PACnet is kind of like a private virtual cross connect fabric, and you can even create a link from, say, Sydney to Tokyo or to Singapore on demand. So what can you buy today? People are buying transit, Tails, any hosted platform, call, voice, desktop as a service. I've got one customer that has a Megaport cross connect into Amazon and is hosting over 700 desktops on Amazon Workspaces and giving everybody just Chromeboxes and things like that to be able to access them. Storage as a service, security, VPNs, video conferencing, load balancing, anything that is really multi-tenantable. So what can you sell? Now, the interesting thing about some of the public VXC fabrics is that everyone who is a customer can be a supplier. So if you can buy, you can sell. So anything that is multi-tenantable that supports VLANs, you can sell to someone else over this fabric. So this is a little view of the provisioning from PACnet type of view and Megaport, to be able to sit there with the slider going, I want 1 meg, I want 10 gig. I want the duration, I want the latency, and I want the locations from this location, say Sydney to Singapore, Hong Kong, Tokyo, so Los Angeles to Hong Kong, anything you want on demand. No waiting for provisioning. Megaport's the same thing as you see there. I pick my port, I pick the VLAN I want, I pick the partner that I'm trying to connect to, I pick the speed, I pick the duration. You'll see the price there for a 1 gig VLAN for a single day is $20. Now, this is generally intrastate, so if you're in the same city between any data center where another person is on Megaport, you can create that on demand. If you're doing intercapital, like from Sydney to Brisbane, it's a per meg, so like $2 or $3 per meg for that duration. So that's how easy, and Megaport, I'm not sure how long it takes to provision PACnet. I think it's pretty much on demand, but Megaport is 60 seconds, and I can do that same thing from my smartphone app. Now, just in Australia alone on Megaport, this is an example because PACnet's kind of private, so everyone who's on PACnet can kind of talk to each other, or you can build your own infrastructure across them. There's many, many people, including international. So if I want to buy a tail in India, I can talk to Tata, or a PACnet or some of the other people that are in Asia and deliver a service to Sydney across these fabrics without actually having to provision physical cables to them. Now, this is one of the interesting parts. In Australia, the base fee of $500 gets you on. That's a 10 gig interface, so $500 per month, includes MLPA, multilateral peering for free. There's 40 gig and 100 gig options. VXCs are connection price and speed agnostic. They don't care if you provision 1 meg or 1 gig. The price per month is $200 or $20 a day. They don't actually care what you provision. The initiator pays. So if you have a multi-tenantable service that you want to have hundreds of people connecting to you, you pay your base fee and you're on. And everyone else pays to connect to you. And the other big thing there is no contracts. So why should you care? This is the future, one of the futures of enterprise delivered services. Megaport's first public, PACNet's more private, IX Australia is coming online, NextGen soon. Megaport's launching in Singapore and Hong Kong in a couple of months. Penn is already in 10 countries and 14 cities, and you can do this if you use their infrastructure. It is extremely simple. If you can do VLANs, you can do this. In the next 1 to 2 years, there are going to be multiple more providers, and it's the US and the UK have already shown interest in this way of doing things. And that's virtual cross-connect fabrics.
Thank you. Yeah. Has anyone got any questions? Anyone got any questions?
You can talk to me after.
Yeah, cool. Cheers, thank you. So Sarah is up next. Tell you who's up next.
Hi, good afternoon. I'm Sarah Escandor Tomas from Association for Progressive Communications. We're actually a nonprofit organization that is based in South Africa, but we are an organization and a network that has global membership. So I've been hearing, since first day, like from the honorable speaker from New Caledonia, that they actually want also to have affordable access to the internet, and my community does research around that, and that is the TV white space. So this is actually a work on ICT for development. Let me just provide a brief introduction of my organization. I won't rush because I don't have any information, and I will provide a disclaimer that I am not personally involved in the project, but I came about this project because of the network I'm in, and I would like to share this within our region because this is actually a project that was done in Africa. Association for Progressive Communication, we were in existence since 1990, and our advocacy is more on to provide open and free internet that brings about social change and development. We work a lot on human rights and the internet, women's rights, and ICTs and ICT for development. TV white space refers to an alternative approach to radio spectrum management that allows for the dynamic reuse of unused spectrum, particularly but not exclusively for television spectrum. This is an important technical and regulatory innovation, particularly for countries that are struggling to provide comprehensive, affordable access to their people. In Africa, they've engaged Google and Microsoft to work in this project. According to Steve Song, who's into this development, for Microsoft and Google, this is very much a case of enemy of my enemy is my friend. They compete in research, mapping, mobiles, and just about everything else. But in this case, Google and Microsoft share an enemy in the high cost of access in Africa. Both stand to benefit from having more Africans affordably online, and in this particular case, for corporate goals are fairly well aligned with the development goal. On that front, they provide support for the dynamic spectrum, Google and Microsoft. Let me just give a few like technical information on the manufacturers and wireless standards. There are an array of competing standards for TVWS technology. First is the 802.22 standard, also known as Wi-Fi, which has evolved out of WiMAX standards. Next, there is 802.11af standard, also known as Wi-Fi, which has evolved in the Wi-Fi standards group. There's weightless standards, which has been put forward by Newell, the developer of TVWS technology. And NEWL developed its own weightless standards because they originally designed for TWS technology for machine-to-machine communication. The demand for TVWS in rural broadband applications became more apparent. They adapted their weightless standards for broadband use. And there's also a production on wildcard called TD-LTE standard for white spaces that's being developed by UA. So pilots are being done in South Africa, which is Google-sponsored, particularly in Western Cape of South Africa, in Kenya, in Malawi, Tanzania, Limpopo province, Nigeria, and other things. So those are just the information, and let me just go to the next slide. If you want more information about this, our organization works on open access to spectrum, and that's our web page. And for Steve Song's blog about TVWS, you can get that. And there's also a book, an e-book about it. So you can read more information and technical information about this. I'd like to share this into this community because I think it's worth exploring this kind of technology. I don't think that it will actually compete with the big ISP providers because this actually addresses to the networks, the community networks in rural areas and faraway areas, wherein we can actually provide affordable technologies for them to get connected in the internet. So, and actually, like we have also like community networks projects. The way they do it is they provide like free infrastructure to the community. But the way they make money out of it, I'm sure everyone gets into this business because we want profit, right? But the way they make money out of this is they provide applications on top of that infrastructure. In a way, you're helping the community to get connected, and then you earn money as well. That's all. Thanks.
Thank you. Mark Smith is up next. Just before Mark comes on, the TV white space is really interesting. New Zealand recently just opened up the regulation to allow a lot of the TV white space, and whenever we go in around the Pacific Islands, people are looking at making a lot of use as well. So it's something really interesting to have a look at. Awesome, Mark. Oh, there we go. Should we sync clock?
We could. Go. All right. IPv6 array is mostly useful, mostly necessary and useful. People seem to not like IPv6 arrays, probably just because they're a bit different. I'm going to explain why you really need to have them. As we probably all should know that there are three components in an IP address: the prefix, the host store interface address, and the prefix length. The prefix length specifies the boundary between the prefix and the host interface address portions. And there's a couple of examples of IP addresses with the portions highlighted. The prefix length, when we assign an address to an IPv4 interface, also describes the addresses that are directly reachable, or the addresses that are on link. And if the address is not on link, then we know to use the default gateway to reach it. In IPv6, however, the prefix length does not indicate addresses that are on link. And there's a subtle but quite a significant difference between IPv4 and IPv6. So this means we have to get the IPv6 prefix on-link information from somewhere else. And that somewhere is from usually IPv6 router advertisements, and specifically the prefix information options, or PIOs. An RA PIO has a flag called the on-link flag, or the L bit, and that specifies whether the prefix or the hosts that receive addresses from that prefix are to consider those addresses on link. Here we can see a picture of a IPv6 router advertisement.
and I've highlighted, obviously, that it's an array, but right at the bottom you can see I've highlighted that there's a prefix information option for a single ULA prefix in this case. There could be multiple prefixes there. Here is the prefix information option itself, and there you can see in the middle I've highlighted the L bit or the on-link flag enabled in this case. So that is why IPv6 arrays are mostly necessary. You might be wondering why I've said mostly. You are allowed to manually configure the on-link state of a prefix. But the trouble is that it needs to be a separate process or a separate step from configuring the IPv6 address. And who'd want to do that on every host? So the question then becomes, why is IPv6 different in this case than IPv4? Well, doing it this way means that we get better support for non-broadcast multi-access networks or links. Some of you might remember frame relay or ATM. We don't really have to worry much about those these days. However, more recently, there is the Broadband Forum TR101 N-to-1 VLANs, where hosts can reach the default router. They're all within the same subnet, but they can't reach each other. So in that case, if you want to talk host to host, you've got to hairpin it through the default router. Another reason could be to trombone or hairpin the traffic through a default router for the purposes of traffic accounting, traffic inspection, traffic filtering. There is one important exception. The link local prefix, or FE80/10, is always considered on link by defaults. Finally, if you want some more information, there was a fairly recent RFC published which explains all this, clarifies some of the misunderstanding. It's called the IPv6 subnet model, the relationship between links and subnet prefixes. And that's it. Yeah, that was very fast, lightning in 4 minutes.
Neither of us needed our clocks. Awesome, thank you.
All right, good. Any questions?
Any questions? You can have 4 minutes. No, all good.
All right, thank you.
Cheers. Next up, we have Andrew from APNIC, who's going to give us a bit of an overview about what's been happening on the wireless network this week.
Apple updates.
That's why I got them to do a lightning talk. Yeah.
So, what we have here is an overview of the network utilisation for this week so far. For those of you familiar with graphs like this, you can see your usual peaks and troughs where we go for lunch and then the sessions after lunch and before lunch. For those not familiar, the graphs work by probing for values every X amount of minutes, and then it gets an average value and a maximum value, and you can see that just here in the small text that we average over the week so far is 6 meg, and the max that we ever pulled during the week was 66 meg, which I would assume was today during some apparent updates. And you can also see it trends the line there, which gives you a good overview of the average as a whole. So usually when you're looking at a graph like this as from a network perspective, if you're not familiar, you'll see a big spike in traffic like this, and you'll always be alerted as to what's going on. And either you find out through delving into the NetFlow data and determining the destination or the source of the traffic and then figuring out what website that is, or you could do a whois update usually, whois check and find out who's the owners of the IPs. In this case, it was just the news that came to me, and apparently someone just mentioned it was an Apple update, and apparently we're all updating our Apples today. But you can see our bandwidth, which was a gigabit link, by the way. It was quite well, had plenty of capacity to handle that update. So continuing on from this, I'd like to talk about the comparison of the V4 traffic to the V6 traffic. For Wednesday, I've got half a day of data. Wednesday's a full day of data, Thursday's half day of data, and the total is the total for the week so far. So what I've done is create, that's lacking some labels, but what I've done is create a comparison here, and this is the traffic of type received. So here you can see of all the traffic on Wednesday, it was 78.6 of it was downloads, and 21.4 of it was uploads. And if you drill down further into this graph, you can see that of the downloads, the source address was a v4 address, being 56.5% of that, and there he is. That one? So what you have on the outer edge actually is which port was the source of the traffic. And this, in the case of received IPv6, you can see that on port 443, 17% of all the traffic was generated from port 443. And on the sent, which is here, on IPv4, the total was 12.2%. But I think the important thing is you can see that, I'll go to Thursday. You can see, again, a large amount of the traffic was downloads and the small percent was uploads, which is quite usual. IPv4 was 80% of the traffic and IPv6 was 10% of the traffic. And then you can drill down further into the ports and see that of that traffic, port 443 was taking up 7% of that. Looking overall at the total week, we can see received traffic was 83% and sent traffic was 16%. Of the received traffic, 67% was IPv4 and 16% was IPv6, which I think is a good amount that shows how everyone is using IPv4 and IPv6 at this conference. So it's not just staff; it's everyone's devices and your mobile phones, and the total amount of all the guests and how much they used in terms of V4 and V6, and that's essentially it from me.
Awesome. Well, I didn't even start the clock. Look at that, stupid. I've got a question. So, do people think those traffic stats in terms of V4 and V6 mix are about right, or was that unusual or surprising for people? Given that we did see that big hit on Thursday, which all of us are surmising is Apple. Wouldn't you have expected more V6 to Akamai? And why?
Because there's a skewing function as a result of the interpretation of what Happy Eyeballs and the operating system and the DNS and the cache's interactions are on best path selection to do this. You get two hits opening up. It's a sin race for some people. You get one thing happening because there's an RTT model being maintained inside the machine, and it's judged based on completely specious reasons. 6 is slower, so it preferences 4. I'm not surprised it was skewed away from 6. We thought Happy Eyeballs, as written, would preference 6. It hasn't had that effect. It's not done the job, and the whole thing about how to preference 6 has gone to a very weird place, which doesn't preference 6.
So the tweet there is happy eyeballs equals sad face. Right, Peter.
Another thing to consider, Peter Lasher, ISC. Another thing to consider is that I don't think the CDN networks are still widely deploying V6. So in the case of Apple, even if they did have a proper V6 address, would they have even been able to pull traffic from any of the CDNs serving the ISOs? They do. But do they? You have to ask really, really nicely, and even then they'll grumble. But yeah, whether it's Akamai or Limelight or whomever, If they don't have V6 turned on, I mean, I would love to have seen all the iOS devices do everything over V6, but.
Yeah, good point. Anyone else? No? All right. Thank you.
Okay, next and the last one I have on the cards, Paul Vixie.
Hello? So I went to Istanbul. I helped moderate a panel, and I thought maybe some of you who weren't in Istanbul might want to know sort of what the geeks are telling the wonks at the moment having to do with internet blocking. The internet was designed for a completely safe culture, you and other scientists. So we developed all of our routing protocols, all of our application protocols to work with people that we would completely trust. That environment changed, but a lot of the protocols and technologies we use have not. And that in turn has spawned not only all kinds of abuse, but all kinds of responses to abuse. Had the internet been designed for an untrusted environment, one might have expected that it would sort of have had some architectural help for those trying not to be abused today. Not so. So given that there's no recourse or accountability for other people who behave in a criminal or abusive fashion, we are, I don't want to say screwed, but the people who are spamming you, abusing you, committing crimes against you are probably not in your jurisdiction. And to the extent that you might have thought you could use whois on the domain name or IP address that they use to attack you, they have many ways of hiding their information. So it is not the case that to use the internet you have to disclose your identity in a way that would let people sue you or arrest you. And that's a sad thing. Anyway, the presumption of innocence is gone, and the focus now is on far-end takedown, if you can, and near-end defense when far-end takedown is not possible. This has created a network reputation system market and an ecosystem. Some of you may remember that I started a network reputation company back in the mid-90s. And that was kind of why I got picked to co-moderate this workshop. So there is an inevitability of intermediaries in network reputation work, because if you have n number of criminals and m number of victims, then you may end up with n times m investigatory actions. That is nuts, right? Try to imagine that you had 1 million criminals attacking 1 billion users. Are we really going to have 1 trillion different investigations as a result? I would say not. Say the actual number is bounded by the number of folks who have the clue and the ambition necessary to do those investigations. And so as a result, most of the victims either do nothing or they depend on security companies or security volunteer projects to do the investigation and the pushback for them. And third parties, in this case, do add value by performing this type of investigation. Now there's certainly a way to overdo this, and that was actually the topic of the workshop, was what happens when the people that you hire or trust as your intermediaries to do your pushback for you take action that itself begins to have a deleterious effect on you or on the overall ecosystem. And one of the reasons this comes up is that there are no guidelines. I mentioned that the internet architecture does not describe response to abuse or defense from abuse. Similarly, our laws don't really admit this. Nothing about national or international law gives us any sort of guidance. Not even English common law gives us guidance about what an anti-spam company ought to do, what their guidelines ought to be. So, of the well-observed risks, we mostly focus on overblocking. What happens if you block someone who did not do the bad thing? What if they were just sort of themselves an intermediary, have no power to stop whatever it is that you think you're blocking? But there are many other things you could do. You might leave an internet reputation block or filter in place long after the abuse has stopped, because you cannot be bothered to sort of keep track of when the abuse has stopped. Another thing you might do is block people in a way that gives them no recourse. Let's say that you've made a mistake and they would like to tell you this. Well, chances are you have done as much to prevent complaints against you as a spammer would do to prevent complaints against them. Those are all mistakes. False positives lead to a collateral damage, which in turn puts the entire field of network reputation work and pushback itself in jeopardy, and risks national laws against the things that we're doing inevitably to protect ourselves. Let me strongly recommend Barbara Tuchman's work, any and all Barbara Tuchman's books that you can find either on Amazon, Kindle, your local library. Read them. But one of the best was her book on folly, The March of Folly, From Troy to Vietnam. And she defined folly as the pursuit of policy detrimental to one's interests. And she went on from there, but that really, that sung out to me as I was preparing this slide deck, because this year, Spamhaus blocked an LIR in Sweden that had handed out address space to most of the Swedish government. And that meant that most of the Swedish government could not send email to their own constituents, let alone the rest of the world. And Spamhaus took an extra 12 mysterious hours to remove this after they had been notified by people they trusted that this was a mistake. I think this is an unnecessary self-driven attack on Spamhaus's own credibility, and I know those people. They're smart and they're good-hearted and they mean well, and they should not do stuff like this that makes them look like idiots, because it will make the rest of us look like idiots for subscribing to their services or coming up with similar services. Another bit of folly: Microsoft decided to sue a company called NoIP.com, a Nevada corporation. And they did this in a bizarre way with what's called an ex parte court filing. Ex parte means one party. That means they wanted to begin with a court order that would cause NoIP's property, including the noip.com domain name, to be reassigned to Microsoft's name servers, without NoIP having had a chance to argue against this in front of a judge. And there was going to be, usually there's a 72-hour hearing, so you have a 72-hour emergency court order followed by an emergency hearing to then discuss it. But the fact is, Microsoft had never notified noip.com that their service was being used by a botnet. So they really had no cause, in my judgment, to ask for injunctive relief. They should have at least sent a cease and desist letter, because if they had done that, they would have learned two things. First, noip.com is an upstanding member of the security industry themselves. And second, they had partnered with Microsoft the year before on a massive takedown in Spain. And I'm sure that the right hand and left hand of Microsoft simply did not know what the others were doing. So a little bit of care would have helped Microsoft there. Right now, I would say the next judge who hears about the need for an ex parte hearing against a supposed spammer is going to say, wait, the last time this happened, it turned out to be a huge mistake. Finally, there's the U.S. Congress and SOPA. A lot of you remember that the entertainment industry tried to drive through some law requiring DNS resolutions to be stopped for websites that were dedicated to infringement, where the definition of dedicated and infringement were difficult. Anyway, it ended in disgrace for the Congress, not the first time, but it means that next time somebody, which might be me, goes forward and says, we need to do something about all the infringing content on the internet, we're going to have the SOPA debacle to step over and answer questions about. I really think that they hurt their own cause by taking such a radically sloppy approach to it all. So the goal of the panel, which went on for an hour and a half, and there's a transcript available as well as a video available, was to explore not only these issues but other issues that people would bring forward, and to try and find the commonalities and see if we could identify areas where sort of some good work could be done. Can I go over time?
How much of it?
2 minutes?
Yeah.
Okay. Thank you. And thank you, last speaker, who only took 6 minutes. Right, so we did suggest in our position paper 7 areas where work like this could get done. And I'll just run through those briefly, very briefly. Please either send me mail or Google for WS107 to find the position paper itself, because it does a better job explaining this than I'm about to do. The ingredients of a framework whereby people in the network reputation industry would all sort of conform to certain common practices that would make sure that folly was not being committed would include 7 things. Accuracy and precision, obvious. Monitor the results of what you do. If it turns out that you overblocked or misblocked, then be ready to revert to the previous config very rapidly. Be transparent, be accountable, make sure that everything you did and why you did it is a matter of public record, so that if somebody wants to challenge that, they're not just listening to you say, yeah, I blocked you and never mind the reason why. Or, no, someone blocked you, it wasn't really me. Actually, if it was you, you should say it was you, and you should say why. You should have the technological capacity to do whatever it is you say you're going to do. Microsoft made the mistake of partnering with my old company, Nominum, I was the co-founder there, who told them stupidly that something like a DNS proxy could be done for a massive scale dynamic DNS site like noip.com. I'm here to tell you, as somebody who's written a dozen RFCs about the internet DNS and who took care of Bind for 18 years, what they were trying to do cannot be done. And had the judge consulted any expert, they would have said, no, that's stupid, you can't do that. So make sure you have the capability to do whatever it is that you plan to do, and that you don't end up doing a lot more harm than good because of your own ignorance. If you are in the business of providing service on the internet and your service can be abused, then be ready to take complaints. Don't set up a robotic mail responder that just thanks everybody for their complaint and then does nothing, or worse, puts it into a queue that's got 10 million other things that never got answered and never will be. Make sure that what you do to block abuse is effective. Don't block, hope that you're blocking action A, B, and C and have no effect on A, B, and C, but maybe have some effect on D, E, and F. And finally, jurisdiction. Unless both the victim and the abuser are in the same jurisdiction, make sure that what you're doing is legal in both jurisdictions, not just in the jurisdiction of the victim. We talked for an hour and a half. A lot of very good things got said. That's going to be the end, except for Kuwait.
Paul, this is Kuwait. I'd like to not comment, actually, try to raise the question you're talking about the SOPA. Don't think about the SOPA only happening in the United States. Actually, the American Movies Association is lobbying in all the Asian countries. As the Asian government, implement similar like a SOPA in their law, actually. And as I know, several of them actually already done. The government doesn't know there is a trick, And actually, sometime last year, this is the American Movies Association also do the same thing in Taiwan. Although the internet community in Taiwan, we are familiar with that. So the industry coming out to say no, and the government stop. But as I know, they are not stopping yet. So if you have, some kind of this is a good common statement, or somebody want to write a statement, and I think I would be help to making a different language, in Chinese, in Japanese, and to tell the government, to tell the community that is wrong. So I think it's somebody need to initiate a statement to tell the government and to tell the operator, some of the blocking actually is not doing good, actually doing bad. and the intellectual property definitely is another good reason to blocking all the things for the community. So I like to echo to you, and hopefully somebody really start to initiate the statement, and that's make in the many different languages, and that the people know, because many people don't know what is harm for them. Thank you.
I have two answers. First, Steve Crocker, Dave Dagan, Danny McPherson, myself, we wrote a response, about 30 or 40-page response to the SOPA, actually to the COECO, which is more or less the progenitor of SOPA, explaining technically why it was wrong and why it couldn't work and why it would do more harm than good and what the various substitute effects would be and so forth. You can find this online. You can find it on Steve Crocker's website. You can find it on my website, redbarn.org. And it, in my opinion, has stood the test of time. I regret nothing we said. It might be that it's missing some things that we've learned since, but in general, that could be translated into many languages and used as policy guidance, in my opinion. We also did some work at previous IGFs. I myself have now attended 3 different IGF meetings under the onus of Security and Stability Advisory Committee for ICANN. And the 2 previous reports both deal directly with DNS blocking, mandated DNS blocking, and the inadvisability of same. And those have already been translated into several languages. The last thing I'll tell you is that during the 14 months of the SOPA battle, I visited the inside of the Washington, D.C. Beltway 24 times. I spent at least 20 business days on the ground there. So if you have stupid legislators in your country, and you have a travel budget,
They have many though.
I have an army of people that you can fly over to reason our way through why certain things should not be done. So contact me.
Thank you.
Awesome. Thank you very much. That's us. So I will give you back 20 minutes of your life. Thank you. You're welcome. I'll see you all back here tomorrow morning at 9 o'clock for the APNIC members meeting. Until then, be safe and have fun.